Welcome to another deep dive. This time we're going exploring the universe. The parts we can't even see.
That's right.
You sent in a ton of stuff,
Yeah.
including a whole ebook, Dark Matter and Energy, unveiling the mysteries of the universe's invisible forces. 95% of the universe is
It's amazing.
made of these things. It's kind of freaky. It's dark matter and dark energy.
Yeah. And, we always talk about the things we can see, like stars, galaxies, planets,
Right. Right.
all of that.
Makes up 5%.
Okay.
So let's start with dark matter.
Okay.
The ebook mentions an astronomer named Fritz Zwicky
Yeah.
from back in the 1930s.
Right.
What was he looking at that just didn't make sense?
He was observing these galaxy clusters. They're these massive groupings of galaxies, and they're all bound together by gravity. But here's the thing. The galaxies were moving so fast, based on what we could see, they should have just been flung apart. Yeah, it's crazy. It's like watching a merry-go-round spinning so fast the horses should be flying off, but they're not.
So did he figure out there had to be more stuff there?
Yeah, he realized there had to be some extra mass that we couldn't see holding everything together.
And that's the dark matter.
That's the dark matter. But here's the thing, and this is where it gets really tricky. Dark matter doesn't emit, absorb, or reflect light.
Oh, okay.
We can't see it.
So it's invisible.
It's basically invisible. Like trying to study a ghost. You only see its effects, not the thing itself.
Oh, okay.
Yeah.
So how do we even start figuring out what it could be?
Well, there are a few ideas floating around.
Okay. The ebook mentions WIMPs, right?
Yeah.
What are those?
WIMPs are these hypothetical particles called weakly interacting massive particles.
Okay.
They only interact with normal matter through the weak force and gravity.
Oh, wow.
Yeah. They're massive, hence the name, but they just pass right through ordinary matter, almost like it's not even there. Like imagine a bowling ball rolling right through a wall.
Okay. Wild. But the ebook also talks about axions and
Right.
machos. That sounds kind of funny.
I know, right?
Like a weightlifting competition or something? What are those and how are they different from WIMPs?
Well, axions are also hypothetical particles, but they're super light. Think more like a feather than a bowling ball. Now, machos or massive compact halo objects,
Okay.
those are things we know exist, like black holes or neutron stars. But maybe there are a lot more of them than we thought. Hiding out in the halos of galaxies, they're so dense they could be part of the dark matter puzzle.
So it's like we have ghosts, feathers, and
Right.
hidden heavyweights.
Exactly.
How do scientists even begin to narrow it down?
Well, it's like a cosmic detective story.
Okay.
Scientists are using some very clever methods to gather clues.
Yeah.
One really cool technique is gravitational lensing.
Oh, okay.
So you know how massive objects like dark matter can warp space-time around them? It's kind of like a bowling ball on a trampoline. Makes the surface dip, right?
Mm-hmm.
And light travels along that trampoline. Its path gets bent by that dip. So when astronomers look at distant galaxies, sometimes they see the images are distorted, even multiplied.
Oh, wow.
And by looking at these distorted images, they can map out the dark matter, even though we can't see it directly.
So it's like dark matter is leaving its fingerprints on the light passing by.
Exactly. It's a pretty amazing way to study something invisible, isn't it?
Yeah. The ebook also mentions something about the cosmic microwave background.
Oh, yes, the CMB. It's radiation left over from the Big Bang, like a baby picture of the universe taken really early on. And there are these tiny fluctuations in the CMB.
Okay, interesting. What do those tell us about dark matter?
Those tiny variations, they're like echoes from the very early universe. They hold clues about how everything was arranged back then, including dark matter.
Right.
And by studying those fluctuations, scientists can build a map of the early universe and see how dark matter influenced the large-scale structure we see today.
So it's like looking back in time to see how this invisible stuff shaped the universe.
Exactly. And there's another tool we use, particle colliders, like the Large Hadron Collider.
Oh, yeah.
These machines smash particles together at incredibly high speeds.
Right.
And they're hoping to create new particles, maybe even dark matter candidates.
It's like recreating the Big Bang, but just a tiny bit of it.
Yeah, trying to coax those elusive particles into showing themselves.
That's amazing. So we have this intricate dance of light, echoes of the Big Bang, and atoms smashing together at crazy speeds. And it's all to understand this invisible force shaping the universe.
Wow.
Yeah, and that's just the tip of the iceberg because, remember, dark matter is just one part of the story.
Mm-hmm.
We still have dark energy to explore.
Okay, let's do it.
Ready to talk about dark energy.
Yeah, let's dive into that.
All right, so dark energy is this force, and it's pushing the universe to expand even faster. Wait, so before we were talking about the universe expanding,
Right.
but now it's not just expanding, it's like
Accelerating.
speeding up.
Exactly. Like imagine throwing a ball up in the air. Gravity should slow it down and bring it back down, right?
Yeah.
But with the universe, it's like the ball keeps going faster and faster.
Oh, okay. So dark energy is like fighting against gravity.
Yeah, you could say that. It's pushing everything apart.
But what is it like, really?
Well, that's the million-dollar question, isn't it?
Yeah.
We're still trying to figure that out. One idea is this thing called the cosmological constant.
Okay.
Einstein actually came up with this idea a long time ago.
Wow, so he predicted dark energy.
Kind of.
Yeah.
He added it to his equations because he thought the universe was static, not expanding at all. But then we found out it was expanding, so we kind of abandoned the idea.
Oh, so Einstein might have been onto something without even realizing it. So how does this cosmological constant thing work?
Well, think about it like this. Space itself has energy, even when it seems empty. And the cosmological constant, it describes how much energy is in that space. And as the universe expands, we get more space, so more energy, and that drives the expansion to go even faster.
So it's like the universe makes its own fuel.
Yeah, in a way.
That's pretty wild. The ebook also mentioned something called quintessence. What is that?
Quintessence is a bit different. The cosmological constant, we think that stays the same. But quintessence, that could change over time. Think of it like a fluid filling the universe, pushing it apart. But the properties of that fluid, they can change depending on where you are in the universe and when.
So with quintessence, the expansion rate could change too.
Exactly. And that's not all. Some folks think we might not even need dark energy at all. Maybe it's our understanding of gravity that's wrong. There's this idea called modified Newtonian dynamics, or MOND, where gravity works differently at very large distances.
So instead of needing dark energy, we just need to rethink gravity.
Something like that. The point is, we're still exploring, we're still debating, and we're still trying to figure it all out.
That's a lot to think about. Okay, so we have dark matter and dark energy, both these mysterious things. But how do they actually, shape the universe that we see around us?
Great question. They're both kind of like architects, but in different ways. Remember we talked about dark matter being like scaffolding?
Yeah.
Well, it's not just holding things together. It actually helped everything form in the first place.
Really?
Yeah. Way back in the early universe, everything was smooth, evenly spread out. But dark matter, it was clumpy. And it started pulling ordinary matter towards it.
So that's how things started clumping together.
Exactly. Those clumps got bigger, pulled in more stuff, and eventually, boom,
Yeah.
galaxies, stars, planets, the whole shebang.
So dark matter's gravity helped make all the stuff we see.
Pretty much. And dark energy, it's got a different job. It shapes how fast the universe expands. It's pushing everything apart faster and faster.
So while dark matter pulled things together to build stuff, dark energy is pushing everything apart.
You got it. A cosmic tug of war, you could say. And the winner of that tug of war, well, that'll determine what happens to the universe ultimately.
Okay, that sounds kind of dramatic. So will the universe keep expanding forever? Or will something else happen?
It's hard to say for sure. A lot depends on dark energy, and as we said, that's still a big mystery. If the cosmological constant is right, then the expansion will probably keep going faster and faster forever.
So everything will just keep moving apart forever.
It's possible, but remember there are those other theories like quintessence. If dark energy changes over time, then the expansion might not always be the same. Maybe it'll slow down or even reverse.
Okay, so it's not a for sure thing that the universe will end up just empty.
Nope, not at all. There are a lot of possibilities.
But even if the universe keeps expanding, are dark matter and dark energy still doing stuff on a smaller scale, like in galaxies and things?
Oh yeah, definitely. Dark matter is super important for how galaxies form and behave. It affects their shape, how they rotate, even how they clump together in groups. Without dark matter, galaxies would be totally different.
So even though we can't see it, dark matter is shaping galaxies.
Exactly. And get this, it can even affect the formation of stars and planets within galaxies.
Wow, so this invisible force is influencing our own solar system.
It's everywhere, at every level, from the biggest structures to the smallest things. It's all connected.
That's amazing. This deep dive is really changing how I think about the universe.
That's what we like to hear.
But I'm also curious about, the things we still don't know. The ebook mentions some alternative theories and the search for proof of dark matter and dark energy. What are some of the biggest challenges facing scientists right now?
Hmm.
Yeah, it feels like we're close to really understanding the universe, but we
Mm-hmm.
still have a lot to learn. What are the biggest things holding scientists back from um,
Yeah.
figuring out dark matter and dark energy?
Well, one of the biggest problems, and we've kind of talked about it
Yeah.
already, is we can't see them.
Right.
Not directly, anyway. And we can't really interact with them either. All we have are the effects they have on the stuff we can see.
Okay.
It's like trying to figure out what a play is about by listening to the sounds coming from behind a curtain.
So scientists are basically working with clues and guesswork.
Yeah, pretty much. And a lot of scientists don't like that,
Yeah.
They want hard proof.
Yeah, I bet.
That's why so many people are trying to come up with new ways to find dark matter and dark energy,
Yeah.
ways to actually see them.
Okay, so like the ebook mentioned, new telescopes and things.
Exactly.
Yeah.
Like, imagine a telescope, but it's way bigger and more powerful than anything we have now.
Okay.
So powerful that it can see back to the very beginning of the universe.
Oh, wow.
And it can make a map of all the dark matter and dark energy and how it's all spread out.
So it's like going from a blurry picture to
Yeah.
a really clear one.
Yeah, exactly.
What about finding the actual particles of dark matter? Is there anything happening with that?
Oh, yeah, there's some cool stuff going on. Scientists are building these detectors underground, really deep underground,
Okay.
to block out all the cosmic rays and stuff.
Right.
And they're hoping that a dark matter particle will just, bump into the detector.
So it's like they're trying to
Yeah.
catch a tiny invisible fish in a huge ocean.
It's a long shot, that's for sure. But if it works,
Yeah.
it would be huge.
Okay, what about the simulations? The ebook mentioned computer simulations.
Right. So scientists are also using computers to try and create models of how dark matter and dark energy work. They can test different ideas that way.
Okay.
And see what might happen to the universe in the future.
So they're looking into space, they're building these detectors, they're running simulations, and it's all to understand these things that we can't even see.
Pretty amazing, right?
Yeah. But with all this talk of dark matter and dark energy, I almost forgot what we were talking about at the beginning.
Yeah.
The fate of the universe.
Yeah.
Is it going to keep expanding? Or, what else could happen?
Well, the universe loves to surprise us.
Okay.
We've only been looking at dark matter and dark energy for a little while, really. There could be all sorts of crazy stuff out there that we don't even know about.
So we could find something new that totally changes everything.
Totally. We might find out that dark energy works in a different way than we thought. Or maybe there's another force out there, something we haven't even imagined yet.
Wow. So right now it looks like the universe is expanding and it's speeding up,
Yeah.
but that might not be the whole story.
Exactly. The universe is always changing, and our understanding of it has to change, too.
This has been a really wild deep dive.
Mm-hmm.
I'm kind of amazed by how much we don't know about the universe.
It's pretty humbling, isn't it?
Yeah, it is.
And the more we learn, the more we realize there's so much more out there to discover.
Well said. We've only scratched the surface of these mysteries, but I'm definitely feeling inspired to keep learning.
That's great. Keep exploring, keep asking questions.
Yeah.
The universe is full of amazing stuff, just waiting for us to find it.
That's a great way to put it.
Yeah.
Well, on that note, we'll let you go ponder all the mysteries of the universe. Thanks for joining us on this deep dive.